Okay, so before we get into the limit comparison test, I needed to add something on to the end of the last video. When I told you this series 1 over n was smaller, we have to know that that is only true for values greater than or equal to 3. For that situation is true for this. So we have to kind of add that stipulation on. All right. So getting into limit comparison test. So this is a little trickier than the direct comparison test, but not too bad. Not trickier, it's just a little bit more work involved. So limit comparison test, we have to have both series have to be positive, and the limit of the two series divided has to be a finite and positive value for this to work. Okay, so if that's true, then both A and B either converge or they diverge. So it's very useful to pick a series that we know how to converge or diverge. Well, it's really, it's going to be the only way this is going to work for you. So it's the same situation. You're given a series and we have to think of another series. So it's very similar to the direct comparison test. So when I'm looking here and it says stuff about disregarding highest powers, but I'm going to make it a little bit easier on you. So what we want to do is we want to come up with a series that we could divide this by to have it so we can take the limit easily. Now what I mean by that is if I divide this by 1 over n squared, and I'm going to get rid of this work here in a minute. If I divide by 1 over n squared, it's the same thing as multiplying by n squared over 1. Okay, so I'm going to skip that step in all the problems. But what we need to know is what this series that we came up with or chose does. Okay, so 1 over n squared is going to be our other series, and we know that this is going to converge by the p-series test because the p is 2. So that's greater than 1. So this thing converges by p-series. So now we're going to put the ratio, we're going to make a ratio here, or divide these two series. And like I said, that's going to involve multiplying by n squared over 1 because we're dividing by this fraction. So if we do that, we end up with n squared over 3n squared minus 4. And we're going to take the limit as n approaches infinity. So if we take the limit as n approaches infinity of this, we could do L'Hopital's a couple times, or we know the rule. If the powers match, we can take the leading coefficients, and we get a 1/3, which is a finite and a positive value. So we can say that both of these would converge because this one converges, and we have this value. Okay, so we can say that this, I'm going to write this series again. Just kind of ran out of room. So if you want to make a mark and draw an arrow or whatever you want to do, we can say that this converges by limit comparison. Okay. LC or LCT, whatever you want to write. You could write it out too. So you could write limit comparison test. But that's how we do that. So let's take a look at the next one. Get a couple examples in. So I want to look for a series that would make this an easy limit. So I want to multiply by root n. So if I multiply the top by root n, I end up with n over n, which is what we want. So I know that the series 1 over root n would diverge because p-series test. It's n to the 1/2. 1/2 is less than 1, so it diverges. P-series. Okay. So that diverges. So if we make this ratio, we think about the limit. So taking the limit of, we get n over n plus 7. That limit would be 1. And this series would diverge. That diverges by limit comparison. And that's what you gotta do. All right, let's take a look at one more example here. Okay, so looking at this situation, I want the highest powers to match on the top and the bottom. So we have a third power on the bottom, first power on the top, so I'd have to multiply the top by n squared over 1. So we need to figure out what this does. Yeah, I'm gonna write it over there. I'm gonna make it over here this time. So 1 over n squared, and this is the one we dealt with in the first example. We have this converges by p-series. Okay, converges by p-series, and if we run the limit as n approaches infinity, n cubed divided by 4n cubed plus n squared plus 5. That limit would end up being 1/4, which again is a finite positive value. So that causes this series to converge by limit comparison. That's it. All right. So again, just like always, let me know if you need any help on these, and we can meet up.